In this lecture, we will conclude the two-part series on internet terminology. We're going to talk about proxy servers, firewalls, and VPNs. There's another batch of terminology associated with internet protocol. We will then briefly go over the 3 states of data, and then there's a bunch of miscellaneous terminology I couldn't fit in anywhere else, and so we've tacked it on to the end here. Essential internet terminology includes the following: client, server, IP or Internet Protocol address, proxy server, firewall, and VPN, virtual private network. A client, very simply, is a device that requests content from a server. Now, after we go over these definitions, I have some visuals to show you. If you're a visual person like I am, then let's make it through these definitions here, and then I think all of this will become a little clearer to you. A server is one that serves content to a client, and one analogy that helped me remember the difference between a client and server is think about a restaurant. A client is someone who visits a restaurant to eat a meal. A server is someone who serves the client. And so think in this case that if you're watching this online on some streaming platform, you are a client. Your client is requesting the video from a server. The server houses all of the videos, is sending that data to you, and then you, the client, are receiving and viewing that data. And so that's the relationship between client and server. IP stands for Internet Protocol, and an IP address is an address used to send and receive data. A proxy server masks or hides a client IP address. A firewall prohibits malicious traffic from entering the network. It is usually located at a network boundary, and so a firewall would be between a client and server, for example. And VPN stands for Virtual Private Network. A VPN directly connects a client to another machine, routing traffic through that machine. And so it acts like a filter, and we'll talk about the difference between a proxy server and a VPN in just a moment. As promised, here's the first visual. And so here we have a client and server. We can see that a client will request data from a server here. The server will then say, all right, here you go, and then serves the data back to the client. With both of these visuals, we have an example of an IP address. You don't need to know why these IP addresses are these particular numbers. That's not important for the CIPP US. Now, in this visual, we're showing what a proxy server is. We have a similar relationship between the client and a server. The client wants to get data from the server. The server wants to serve the client that data. But in this case, we have a proxy server that is acting as a filter. And so what this does is, let's just say this proxy server. There are different types of proxy servers. We'll just say that this one serves the client. Then so the request goes through the proxy server to the server, and then the server is going to take that request and process it and send it back. Perhaps the proxy server says, oh, I didn't want this data. It's going to drop it. And so the proxy server is representing the client here. If this is what was expected, then the proxy server will send it on to the client. Here we have an example of a firewall. Now, one of the primary differences between a firewall and a proxy server is firewall is going to have a lot more functionality. It can do a lot more work than a proxy server. In this case, let's imagine that the firewall located here in our relationship is the choke point through which data gets to these 3 clients here. And so I've used this dotted line to indicate that this is a network, let's say an organization. We have our 3 work computers. They're each on different IP addresses. And what will happen is these clients will ask for data from a server. And if the firewall is configured to allow the data from the server to pass, then it will come in and the clients will receive the data that they've requested. And so the firewall allows that data to traverse the network boundary. Now, let's say we have a bad actor. So just look at these 2 IP addresses for a second. The firewall is configured to allow data from this IP address. However, this bad actor, for example, is a known bad actor. So the firewall has been configured to say, hey, if we receive any data from 172.31.2.2, then I want you to drop that data. And that's what's going to happen. The bad actor may be trying to get into your network to steal passwords or cookies or authentication tokens or something like that. The bad actor is going to try and send bad traffic here. The firewall is going to say, this is a bad IP address, and the firewall is going to drop all of that data. With regards to a virtual private network, again, we have our network here, and the difference here is that this is still company property, but over here we have a remote client. And so, perhaps this is you're working from home. Today you're not in the office, but you need something that's on a company server, okay? Well, if you tried to connect directly to the server is going to say, wah, 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 I don't know this IP address. Essentially, the firewall has said, you are not allow listed. And so part of our firewall configurations will be, you're going to put in what IP addresses are allowed to enter the network boundary, and all other IP addresses, if you're not explicitly allow listed, then you're going to be denied access. And so that's what's happening here is, you're at home, you're trying to access company resources on the company network, and you're unable to do that. Well, one workaround is to use a VPN, a virtual private network. And so you likely have something configured either on your company laptop or perhaps something you configured yourself. You connect to the VPN, and now what happens is, even though you are remote, the company network thinks that you are located inside of the boundary. So you're going to be able to access the data that you need that's on this company server, because as far as the server is concerned, you are already inside the network. And so that's one thing that a VPN will help us do. IP-related terminology. You need to understand the difference between a static IP address and a dynamic IP address. In short, a static IP address is one that does not change, whereas a dynamic IP address changes regularly. There are currently two widely used versions of the Internet Protocol, or IP. There's IPv4, which stands for version 4, and IPv6 for version 6. The current IPv4 is still widely used, but one of the problems with this older version of Internet Protocol is that it only had 4 billion possible addresses. Again, if you think back to the beginning of the internet, I'm sure at some point someone said, oh my gosh, 4 billion addresses. We're never going to get 4 billion people on the internet. And of course, we've way surpassed that. And how we've done that is unimportant for the CIPP US. What you need to understand is that one reason that we've moved towards IPv6 is because it allows several orders of magnitude more IP addresses. There's also a lot of convenience and security that's built into IPv6. So the main takeaway here is that IPv4 is an older version. IPv6 is newer. The IPv4 format is going to be as follows. Think of it just as in like 4 different chunks, okay? So we've got 192.168.1.1. That's a little device that might help you remember IPv4. And IPv6 is much, much, much longer. Why it looks like that is unimportant. And if you're interested in knowing how many possible IPv6 addresses we have now, there are 65,000 addresses available per square foot on Earth. That's 10 to the power of 37. So, here we are in 2020, whatever, nowadays saying, oh my gosh, there's no way we're going to have that many people on the internet. But I don't know, maybe, I imagine if we ever have that many devices, we'll probably be on multiple planets. And hopefully those planets, if they have to rebuild the internet infrastructure, will do so with security in mind. And that'll make everyone's life a lot better. All right, now that we're done with IP terminology, let's take a look at the 3 states of data. These are data at rest, data in transit, and data in use. Data at rest is data that is not being accessed. It is data that is stored on a hard drive, for example, And the protection method, it's important for each of these states of data that you remember how we protect that data. We protect data at rest with file or disk level encryption, or perhaps both. You can encrypt a file and then encrypt the disk that it's on. Data in transit is data that is en route to a destination. For example, you have an email, you have attached a Word document to that email, and you're sending it to a colleague. This data is in transit. It is moving from your computer to your colleague's computer, and we can encrypt data in transit by using an encrypted tunnel, such as a VPN or SSL TLS. And finally, we have data in use. This is data that we are using. It is being manipulated or changed by a user. For example, if you open up a Word document and you're making revisions using track changes, then that is data that's being in use. A few ways that we can protect data in use is by using a clean desk policy. This is just referring to actual paper documents themselves. We don't want to leave out any file folders or physical papers that we don't want other people to view. We can also use PC locking. That just means that, if you're not typing or using the mouse, if there's no activity on your computer for a certain amount of time, maybe 5 minutes, your computer will automatically lock itself, and then you need a password to log back in. No shoulder surfing, meaning that if you're looking at sensitive data, you don't want someone standing behind you. They could possibly see that data. And finally, privacy screens for monitors. You may have seen these. It's a screen that you can put on the monitor. And if someone is at an angle looking at your desk, they won't be able to see the screen clearly or perhaps at all. It may be completely blacked out to them. Some miscellaneous terminology you need to know. Caching is when web data is saved locally on your computer. And what this does is it speeds up the loading of a web page faster. Let's say, for example, that you use the same email client and you use a web browser to access your email. Well, if you have any graphics that are typically displayed on your web browser, those may be located locally. They're on your computer. That way, when your computer is requesting data from the email server, you don't need to download those graphics all over again. A web server log. These are records of user access history. So if you think back to the visuals a few slides ago about the computer network, for example, and needing to access that computer network from home, the VPN, for example, or the firewall, or every time that data comes in through the firewall, anytime someone logs into the VPN, there will be a record of that usage. So if any type of digital forensics need to be done to determine who used the company resources at a certain time, there's a record of that. Internet Service Provider, or ISP. This is a company that connects clients and home networks to the internet. And TCP, Transmission Control Protocol. This is a connection-oriented protocol that helps to facilitate data delivery. You often see TCP and IP together, so TCP/IP. And finally, JavaScript. This is a programming language that creates dynamic content on a web page. Flash is an old Adobe web technology used to display videos on web pages, and it is no longer supported. And finally, a type of cyber attack you need to know about is cross-site scripting. Now, I know cross starts with a C, but the acronym here starts with an X, XSS, cross-site scripting. This is a malicious attack, and it usually happens like this. A bad actor will inject some code onto a seemingly safe web page. A user will unknowingly interact with that code, and when they do so, they're deploying the malicious script. And so let's just say you visit a website and you log onto the website, you're surfing content, and all of a sudden, a button pops up and the button says something like error or, surprise, you're our 1 millionth customer today. Click here for your reward or whatever. And so as soon as you click OK, you're unknowingly, perhaps, downloading a virus onto your computer, or you may be unknowingly transferring some authentication token or ID from your computer onto the malicious actor. All right, at a high level, that's what happens. So cross-site scripting is a way for hackers and other bad actors to trick users into doing things they normally wouldn't do. In part 2 of this lecture series, we have looked at proxy servers, firewalls, and VPNs. Terminology you need to be familiar with includes client, server, internet protocol, IP address, proxy, firewall, and VPN, virtual private network. You need to understand the difference between static and dynamic IP addresses, and you need to know the difference between IPv4 and IPv6. Again, just at a very high level, IPv4 is older, IPv6 is newer. You need to know the 3 states of data at rest, in transit, and in use, and you need to know what are some protections for each of those data states. Finally, some miscellaneous terminology you need to be familiar with: caching, web server log, ISP, TCP, JavaScript, Flash, and cross-site scripting.